Hello, welcome back. Now let's understand the jump operation in the RISC-V architecture. In order to figure out the jump operation, you are recommended to understand those four assembly instructions. Remember that every time you look into any assembly block or assembly routine, identifying the control flow of at the software level is important. Let's look at the J and JR assembly instruction together. If you run J assembly instruction, conditional jump operation is performed. Whenever J assembly instruction works, execute it, and you're going to see that the address to branch is also specified. For better understanding, let's look at the example assembly instruction. And please take a look at this. This is the J assembly instruction with the address to jump. So if you run this assembly instruction, the program counter will be updated to have this address. And let's take a look at the JR assembly instruction. The basic operation of JR assembly instruction is identical to J assembly instruction. The key difference is the address to jump is stored in any of the general purpose register. So let's take a look at example assembly instruction for JR assembly instruction. As you can see, this JR assembly instruction is organized with the A1 register. You know that A1 is one of the general purpose register in RISC-V architecture. So if you run this assembly instruction, the program counter will be updated to the value in the A1 register. Important thing is, before you run this assembly instruction, checking the value of the A1 register is important. Because as for this assembly instruction, address to branch is already specified, but unlike this assembly instruction, in JR assembly instruction, it does not specify the address to branch. Instead, address to branch is stored in this kind of register. That is important thing when you debug this assembly instruction. So let's take a look at another important instruction, that is JAL assembly instruction and JALR assembly instruction. JAL instruction support the unconditional jump operation, just like J and JR assembly instruction. But important thing remember is that while jumping into the address, the return address is updated to the link register. What is link register in RISC-V? That is the X1 register that is in the architectural name of the register, and X1 register is the RA register, that is return address register in the form of the AVI convention. This is an important operation whenever you debug JAL assembly instruction. So for better understanding, we need to analyze the example instruction related to JAL assembly instruction. Just like J assembly instruction, JAL instruction is structured with the address to branch. In this case, the program counter will be updated to the start address for this symbol. key difference between J and JAL assembly instruction is that while branch to the address like this, the RA register will be updated to have the return address. So it's time to review the last assembly instruction, that is JALR assembly instruction. This assembly instruction supports unconditional jump operation just like JAL assembly instruction. Only difference is that address to jump can be found in the general purpose register. And just like JAL assembly instruction, and if you run JALR assembly instruction, the link register will be updated to have the return address while branching into the address to branch. So here is the sample assembly instruction for JALR assembly instruction. Unlike this assembly instruction, this instruction is with the RA register. RA register is one of the general purpose register in the RISC-V architecture. So in this video, we analyze the list of the jump assembly instruction in RISC-V architecture. As I mentioned earlier, understanding those kind of assembly instruction for jump operation is extremely important, and because understanding the control flow of the software is important, I'm sure that you're going to see those kind of assembly instruction 100%, and you will going to debug this assembly instruction with 100%. Thank you for watching this video. See you next time.